Welcome to CSP 340, Chapter 10, Developmental Disabilities and Intellectual Disabilities. This is a supplemental to that chapter. This is about causes. Your textbook doesn't go much into causes, and so this is just my little mini primer on biological causes of developmental disabilities. When we talk about biological causes, there are causes that are related to genes and chromosomes. They have what we call single gene disorders, autosomal disorders, and sex-linked, which we'll talk about in just a minute. Then we talk about chromosomal disorders, disorders in the number of chromosomes and disorders in the structure of chromosomes. And then we have what we call multiple or unknown causes, and then we've got a little bit about genetic testing and a little bit about genetic counseling. So a review of how genes and chromosomes work. Your genetic code is written on your chromosomes. Through meiosis, the human genetic material is replicated and then divided. Your genetic code determines things like your gender, eye color, height, as well as holding markers for diseases such as cancer and disabilities such as sickle cell anemia. So for single gene disorders, what we call autosomal dominant, the way this works is if one of your parents passes the gene on, then you get the condition. It can also occur through mutation or new occurrence in that family's line. It results in structural defects like skeletal, muscular, malformed organs or tumors, and they tend to be less involved than autosomal recessive disorders. And you can have differences in expressivity or symptoms and penetrance, whether the condition is actually present. So an example of one that is not having to do with developmental disabilities, my brother has a condition called nail patella syndrome. He has a little tiny thumbnail, and he also has malformation on his kneecaps. His son has the same condition. His son has little tiny thumbnails. He has only cartilage, no bone in his kneecaps, and he has hyperflexible joints. So they have the same condition, but my brother has less expressivity than my nephew has. We don't know where it came from. Because it's dominant, we should have seen it before my brother, so we're assuming that it was a mutation. The conditions that are autosomal dominant that lead to developmental disabilities are those where there are tumors that grow on the brain or in the nervous system. Then we have single gene disorders, autosomal recessive. You hear about people being carriers. That's autosomal recessive. The way that works is if you receive the gene from your mother or just from your father, then you're a carrier. You have no symptoms, but you can pass it on to your children. For you to have the condition, you have to receive that gene from both parents. And these typically result in metabolic disorders, disorders in how your body processes lipids, protein, or carbs. Two conditions that are autosomal recessive, Tay-Sachs. It's on the 15th chromosome. The person is missing an enzyme that metabolizes a lipid or a fat. This person starts normal till about 6 months old, and then they start regressing, and they're dead by age 5. Not routinely tested, but people who are from Eastern Europe and are of Jewish background, then they need to be tested because that's the most common group that has this. Then we've got PKU. It's on the 12th chromosome, and it is identified through routine infant testing. Every child in America is tested for PKU shortly after birth. And what happens is that the child cannot metabolize Phe, and if the Phe builds up, then they have brain damage. And it's treated through diet. Then we have sex-linked genetic disorders. The most common genetically inherited disorder is Fragile X. It's carried, what happens is that the person's X chromosome is weak. It has a shortened arm, and it's one of the few genetic causes of autism, more common in boys than girls. Then we have sex-linked genetic disorders, Rett syndrome. Now, I put this one on here because we had mentioned this in an earlier chapter. Almost all new mutations, almost all girls, they're usually born healthy and stay healthy for about 18 months, and then they begin to lose skills, and they lose physical skills, motor skills, and then they get disorganized breathing. They're irritable, and very often it is misdiagnosed as autism at first, but it soon becomes obvious what it is. Then we've got chromosomal disorders. We've got the disorders of number. Non-disjunction is during meiosis. When it duplicates, it doesn't split properly, and so instead of getting one 21st chromosome from your mom and one from your dad, you get two from your mom and one from your dad, and so now you have three chromosomes. That, by the way, is Down syndrome. Translocation is where part of the genetic material from one pair of chromosomes drifts during meiosis and ends up with a different pair, and there is a form of Down syndrome where the 15th or the 18th joins the 21st. And then mosaic Down is where after the first split, then when they duplicate again and split, that's when the translocate or non-disjunction occurs, and so you end up with 46 chromosomes in some of the cells of your body and 47 in another. And then we have deletions where we lose some genetic material, and then we have what are called one-sided disorders and uniparental, which I'm not going to talk about. Thinking about causes, we have here in Cleveland a pair of twins, Austin and McCullough, and they're 23 now, and she got her degree in political science. And so what's the difference between Austin McCullough? One chromosome. He has Down syndrome and she does not. The way it works is you have 46 chromosomes, 22 pairs of autosomes, and a pair of sex chromosomes. During meiosis, the germ cell is split into two, and each gamete has 23 chromosomes. Sometimes when this split is made, one of the pairs doesn't separate. And so they get both of one pair and nothing from the other pair. And that's what I explained to you before. By the way, there is one, what we call unisomy, or monosomy, which is where somebody doesn't get anything from one parent, and that is XO syndrome, which is Turner syndrome. Always girls and causes learning disabilities, but not developmental disabilities. Autosomal non-disjunction, trisomy. Down syndrome is the most common trisomy. It's the most common biological cause of intellectual disabilities, not inherited, but biological. And it's linked to maternal age. Then we have another one called Edwards syndrome. You may have seen during the presidential election, Senator Rick Santorum's daughter, Bella, is a trisomy 2018 child. They usually don't survive after the first year of life, and they have microcephaly, small head. Sex-linked non-disjunction, we have Klinefelter syndrome, which is XXY, and Turner syndrome, which I mentioned to you before, which is XO. Neither one of those lead to retardation, by the way. And I have lost my cursor. There we go. And my slide has frozen. Okay, so the next one that we have is Williams syndrome. And Williams syndrome is very interesting because people with Williams syndrome have cognitive disabilities, but they also have striking verbal abilities, high social personalities, and an affinity for music. And that just doesn't usually happen with the IQ range that they have. Then we've got other biological causes. We have hydrocephalus, which is buildup of cerebral spinal fluid in the head. If it's untreated, it leads to brain damage. Then we've got microcephaly and macrocephaly. Macrocephaly being a larger head than normal, and then microcephaly is when the person has a small head, and that usually leads to profound intellectual disability. So, some of the things we can do for genetic testing: we can do carrier identification, trying to figure out who is carrying particular genetic conditions. If they run in families, then you might want to be tested. Prenatal screening, which is where we can actually have screening while the person is pregnant. And then newborn screening, which is after the child is born.